Hello everybody, welcome back to another tutorial for Computer Science Education Week 2020. In these tutorials we're covering game programming using JavaScript and the Phaser game programming library. I want to keep things moving pretty quickly, so we'll get right back into it, reviewing a couple things and picking up where we left off last time. So, once again we're using the Phaser game programming library. I'm no artist, so we're using art provided very kindly by a person named Kenny. We're doing our coding in the Phaser Sandbox, which lets us just type in the code and test it immediately. And if you don't have the code we did yesterday, you can copy it from this URL to get caught up. Alright, so I'm actually going to go ahead and do that now. So this is the Phaser Sandbox. I'm going to go ahead and delete what's already there. Go to that URL I mentioned. We'll highlight everything here. Use Control A, Control C to copy, or you could also use the right mouse button menu. Bring it over here, Control V to paste, and here we are. This is where we left off yesterday. I put in a couple blank spaces at the top. Those are going to bother me, so let me remove that. Alright, so we are right where we were yesterday. So let's run this code to remind ourselves what we had yesterday. So we have our character called TM. We have a physics system. There was gravity that made him automatically fall. And we have this ground made out of little blocks that we added to the scene. What we don't have is any way to control TM, and without that, that's not much of a game. So we're going to work on adding that now. In order to do that, we need another global variable, which I'm going to add to the global variable section right here. I'm going to call this variable controls. Remember, we use global variables because this has to be shared between both the create function and the update function. So I have established the global variable here. Now I actually have to give it a value inside the create function. I'm going to say controls equals this. Remember, this is basically a little handle that we have that gives us access to the systems that Phaser provides. And it has little components inside of it. So we're going to use the input component, so this.input. And then inside of that, the keyboard. And then we're going to use a function called create cursor keys. And this will create an object that will be useful for us to monitor the arrow keys on the keyboard and use it in controlling our character. Now let's move down to the update function where we can actually use it. Remember, the update function runs over and over again, many times a second. And so that's the perfect place to monitor what the player is doing and respond to it. So we're going to do that. To do that, we need the if statement. An if statement lets us do a certain action or actions if and only if a certain condition is true. So if, and here's where we're going to use controls. Controls has a property right that corresponds with the right arrow key on the keyboard. And that has a property called isDown, which through the magic of Phaser will be true if and only if the right arrow key on the keyboard is being pressed down. So now we've got to decide what to do if the right arrow key is pressed down. Well, we need to move TM to the right. To do that, we're going to use a function that's part of TM. It's going to be set velocity x. So velocity is another word for speed. So we're going to give TM some speed in the x direction horizontally. We don't want him moving up or down. So we're going to give him some speed in the x direction. And I'm going to say 160. The bigger the number, the faster he'll go. 160 is pretty reasonable. And because we have a physics system built in, just telling the computer that he has a velocity, the physics system will take care of actually causing him to move. So let's run this and see if it does what we expect it to. Starts as usual. So I'm going to press the right arrow key and notice that he moves to the right. What you can't see is that I let up on the right arrow key and he kept moving to the right. So we're going to need to fix that. We're also going to need to make some way for TM to move to the left. In order to do that, we need to add more parts to our if statement. So we have if, we can add an else part. And else says, okay, if that first condition is not true, check this other condition. So we check to see if the right arrow was pressed. Now we're going to check to see if the left arrow is pressed. So else, else if controls dot left is down. So that's going to work almost the same way. Set velocity x. The difference here is that the velocity needs to be negative to make TM move to the left. Remember, positive x is to the right, negative x is to the left. So negative 160. And before we test this, let's go ahead and add one more thing so TM can actually stop. So first we check to see if the left arrow key is pressed. Then we check to see if the right arrow key is pressed. If neither one of those things is true, we're going to use a final else. No if there, because we're saying if it's not the left, not the right, we don't care. We're just happy it's not the left and the right. Then he stops. That means that this velocity needs to be 0. So set velocity x 0. And now we should be able to control TM and have him move to the left and the right. Let's run the code and see how that works. So move to the right, stop, move to the left. Ta-da! So you may be thinking, okay, he moves, but he's just kind of gliding along the ground. That doesn't look very good. We are going to add animation a little bit later on. But before we do that, I want to add one other feature. Let's give TM the ability to jump. So we're going to use the up arrow key to jump. And so as you might imagine, that works a lot like the left and right. We're going to say if controls up is down. It's a little confusing, but we're checking the up arrow key and we're seeing if it's pressed down. We're going to, well, what do we need to do? Well, we moved left to right by doing set velocity x. To move up, we need to do set velocity y. So TM dot set velocity y, and here we need to use a negative number. Remember, in computer graphics, positive y goes down. So a positive y here would tell TM to try and move down, and he just run into the ground. So we need a negative y to make TM move up. I'm going to use negative 300. That'll make him jump pretty high. You can tinker with that number to change it to see how high you want to make him go. But let's test this out. So left and right still work. And now he can jump. And that looks pretty good. There is a small problem that we can see. If we jump and jump in the air, he can go all the way to the top of the screen. He can jump in the middle of a jump, which is not very realistic, although it's kind of cool. So we need to fix that so he can only jump if he is standing on the ground. That's actually not too hard to do, thanks to a pretty nifty system built into Phaser. But we need to go down here and change this condition that's part of our if statement. So we want him to jump if he's on the ground. We want him to jump if we have the up arrow key pressed and if he's standing on the ground. Well, in JavaScript, and checking if one condition and another is true is represented by two ampersands like this. And the way to check to see if a sprite is touching another sprite, so in this case we want to know if TM is touching the ground, we can say TM dot body. The body basically represents the physics of TM touching, and then we want to know in what direction. Well, we don't care if he's touching something left, right, or on top. We want to know if he's touching down. So this says if the up arrow key is pressed and he's touching something below, then jump. Otherwise, don't jump. Even if the up arrow key is pressed, if he's not touching down, he won't jump. So let's see if that fixes the problem. So now, if we jump, can't do a double jump. I'm hammering on the up arrow key here, and he's only jumping when he's on the ground. So we have fixed that part of the problem. So now let's talk about adding animation to the game. In order to do that, we need to learn about something called a Sprite Sheet. This is an example of a Sprite Sheet. Yesterday, when we added TM to the game, we used a single 96 by 96 image of him standing still, sort of facing forward, to represent TM. A sprite sheet contains multiple images in the same image file. As you can see here, they're lined up. Here's that idle image. Here's a jumping image. These two are a sequence of TM walking, and here's two of TM climbing and ducking and celebrating. The numbers here are actually not part of the sprite sheet. I added these so we could refer to them more easily. But the idea here is we can use a sprite sheet to represent multiple views of the same character. And by doing that, we can use multiple views to create an animation. For what we're doing today, we're only going to be using these top 4 frames of the sprite sheet. And when you refer to a sprite sheet, it's divided into rows and columns, so we can see that it's 2 rows and 4 columns. And the individual images are numbered left to right, top to bottom, as you see here. So this is image 0, 1, 2, 3, 4, 5, 6, 7, starting at 0 as we usually do in computer science. So now let's go back to the code and we'll see how to actually use this to incorporate animation into our game. So, in order to use a sprite sheet, we need to load it from the server the same way we load everything in the preload function. And this is actually going to replace the single image of TM we were using earlier. So I'm going to comment out this line. Remember, comment out means put the 2 little slashes in front so the computer ignores it. And replace it with a similar line. This load, not image this time, but sprite sheet. I'm going to give it the same name. And the path here is assets / tile sheet / character .png. But we need to give more information. The Phaser system needs to know how to split up the sprite sheet into the individual images. So we need to tell it how wide and tall each individual box for an image is. We do that with a little object as the next argument that has 2 properties, frame width, and just like the single image of TM, it's 96, and frame height, and that is also 96. I need to spell height correctly. I really need to spell height correctly. And end with a semicolon. Alright, so that will load the sprite sheet instead of the single image. So let's run the code. And we see that nothing has actually changed. Even though we've replaced that one image with that sprite sheet containing 8 images, it's only using the single frame in the upper left-hand corner. We could tell it to use other frames if we wanted to, but if we don't, it uses frame 0, the one in the upper left-hand corner. So we're in a good position to now move into adding animation. The syntax for adding animations is a little bit involved, and to save a little time, I'm not going to make you watch me type it, so I'm going to cut and paste this from another document I have. And now we'll look at this. So we're using the old this. Let me put an extra space here. We're using the this, and then a property of that called anims, which stands for animation, and create. And that takes an object, notice the curly braces here, with several properties. Here are the ones we care about. Key is just a name for it. So the first one is the idle animation, when TM is not doing anything. Down here I'm creating one for jump and one for walking. Then the frames, this is an array. That's what the square brackets mean, so it's a list of things. Each thing inside the array is an object. One property refers to the sprite sheet to use, so we're using the TM sprite sheet, and then the frame property refers to which frame. So we're saying the idle animation is built from frame 0 of the TM sprite sheet. The frame rate is how many frames per second to show, so how fast or slow to run the animation. If the animation is only one frame, it doesn't really matter, especially because this is not going to repeat at all. So you can put any number you want there. Okay. The jump animation is the same. It's a single frame, has a different key, jump, and this time it's not frame 0, it's frame 1. The walk animation is a little bit more interesting. This time, the frames has 2 objects in it. See, curly braces and then another set of curly braces. So the first frame comes from the TM sprite sheet, and it's frame 2. The second one is from the TM sprite sheet, and it's frame 3. So when this displays, it will actually display frame 2, and then in the next time, frame 3. And this repeat property, repeat -1 means repeat forever. So it's going to keep doing that, switching between frame 2 and frame 3, which will actually make it appear to be animated. The frame rate here actually matters because there's actually change going on. 6 to me looked pretty good when I experimented with this earlier. You can toy with this number to see what looks best to you. It will affect, how fast or slowly it appears that TM is walking. If we run the code at this point, nothing will be different because although we've created the animations, we haven't actually told Phaser when to use them. To do that, we need to go to our update function and add some things to make it play the right animation at the right time. So, if the right arrow key is pressed down, we want to move to the right, and we want to play the walking animation. So to do that, we're going to add another command inside the curly braces that go with this if statement. And it's going to say TM anims, so play the animation. So we're going to play the animation called walk. And we're going to use a second argument that's just true. That will keep it from replaying the animation if he's already walking. Okay. Now, let's do the same thing. We also want the walk animation to play if he's walking to the left. Same format. And we want the idle animation to play if he's standing still. So that will be tms.anims.play idle, and again, true. And we want the jump animation to play if he is jumping. So tm.anims.play jump true. All right. So now if we run this code, we should see animated TM moving across the screen. So look at that. He moves left to the right. We get the animation, jumps. Okay, well that's something, but I still think there are a couple of problems. For one, when TM walks to the left, he doesn't actually face to the left. And for the other, the jump animation doesn't really play. You can kind of see it for just a second at the beginning, but he doesn't stay jumping while he's in the air. So we need to fix both of those things. Fortunately, they're both pretty easy to fix. If you recall our sprite sheet that we're using for TM, all of the images show him facing to the right. So one possible solution in this would be to make another sprite sheet that had some images of him facing to the left and use that instead. But we're not going to do that. Instead, we're going to use a function in Phaser that will allow us to flip the image right to left when he's moving to the left. So we need to do this when he's moving to the left. We're going to do tm.setFlipX, and this is a true or false. If it's true, yes, flip him. If it's false, don't flip him. So let's do setFlipX to true and see what happens. So now he walks to the right. When he walks to the left, he flips. Uh-oh, but now he stays flipped if I walk back to the right. We need to have some way of flipping him back if he's going to the right. Okay, well that should be easy enough. If we set FlipX to true when he's going left, we must set FlipX to false when he's going to the right. So let's see if that works. So yes, yes, yes. That's great. Notice one nice side effect of this is that he stays flipped when he stops moving. So if he was moving to the left, he stands still, but he stands still facing to the left when you let up on the arrow keys. Fixing the issue with the jump is a little bit tougher because we see we still have that. The jump animation does not stay playing while he's in the air. As I was planning this lesson, it actually took me a little while to figure out what's going on here. See, the problem is these if statements are separate. First, we check to see if we're moving right or left, and if not, we go into the idle state. Then we check to see if we're jumping up or down, and if we are, then we go into the jump state. But the problem is when we jump, we usually press the jump button and then let go, which means when it goes through this on the next time through the update loop, it's going to get here and see no left, no right. So do this, which means play the idle state. No jump, we're not on the ground anyway, so don't do anything else. So the most recent change after we've jumped is into the idle state, which is just the plain not jumping image. So the way to fix that is to separate the jumping animation from the jump controls, because we really want him to look like he's jumping whenever he's in the air. So I'm going to take the jump animation out from this if statement, and we're going to make a new if statement. This one says if, and then an exclamation point. An exclamation point means not. So in a condition, it means the opposite of what that condition says. So let me put it in here. So TM body touching down. So TM body touching down is true if TM is on the ground. By putting a exclamation mark in front of it, we make that the opposite. So now this is true if he's not touching the ground, if he's in the air. And so if he's not touching the ground, that's when we want to see the animation of him jumping. So tm.anims.play jump true. Now if we run this code, notice that as he's falling, he's already in the jumping posture, which is a little bit weird, but doesn't look that bad. But now if he jumps, he goes into the animation and he stays jumped. And notice he can move in the midair, and that looks pretty cool. I mean, you might disagree, and if you don't like the way this looks, you could change it back so that he has the running animation in the air. But I think this looks pretty good. All right, I think we're going to stop here. This has already been a pretty long video, so we'll pick up next time and add some obstacles and other scenery to the world. Thanks for listening. Bye-bye.